All right, last term, I introduced you to calculus or differentiation. We will start off again to remind ourselves what is the purpose of derivatives. So we're going to go all the way back to first principles. Out of curiosity, I know you don't need to know this for next year or you're not getting examined on this, but what is the first principles again? What's the formula? Anyone remember? Hands up if you do. Yes, Dylan.
Then h goes to 0, f of x plus h minus f of x over h.
Very good. This is called h approaches 0, and then the notation is f dash of x. Okay? Can someone describe to me what is this formula essentially getting you to find? Gradient of what, Matt? Okay, so let's think about you're onto something. I'm missing just one key word here. You're right. It is the gradient at one point. You've got a curve. The gradient of what though?
Tangent.
It is a gradient function of tangent. What is a tangent though?
Tangent is just like a line that just touches the graph.
At that one point. Okay, so let's put all the things you said together before. You said it's a gradient at one point, right? But remember, gradient means it's the slope. So the slope of a line, we call that line tangent line. So this line touches at only one point on any curve, not a straight line, just talking about a curve. So say this point can have a straight line, which we call the tangent line, a straight line that only touches that curve at that one point. Okay, so this curve is your f of x. What you're interested in finding is what is that line when it touches that point. Okay, now that line, we know it is a straight line, so we call it y equals mx plus c. This is called a tangent line. So I'm going to write up here. Call it a tangent line. The line, we know it's a straight line, but tangent because it touches the curve at one point. What you're able to do with derivatives, which is this first principle, so f dash of x only allows you to find m. That's it. That's all you're doing. This whole differentiation technique that you're going to learn, chain rule, power rule, quotient rule, log rule, exponential rule, all of those rules is simply to get you to find that. Okay, so they will always have to tell you to some degree what the gradient is or what that x point is. That's what they're always going to have to do. Okay, so if you understand that the questions in the exams next year are only going to play around with that. They're going to play with the straight line, the function, the x or y coordinate, but whatever it is, this is pretty much the makeup of it. And so if you understand the concept, when you're dealing with the problems, you're just doing like a jigsaw puzzle. You're like, oh, I got a point, but I'm missing c, or I've got c, but I'm missing the gradient for this. And that's where you're using derivatives to solve the problem. But that's it. These are all the pieces that you need. Okay? Now, then we said, okay, so the first exercise I taught you in 17A was how to find the derivative function, which is what Andre was talking about before. He said that's the gradient function. So I'm going to write here. This gives you the gradient function. But there had to be a shortcut. Well, not that there had to be, but there was shortcuts that we can do instead of doing first principles all the way. It takes too long. I taught you the first rule. The first rule that we learnt was called power rule. So I'm going to write over here. Power rule. Power rule only works when you have a function that is a power or polynomial. What does polynomial mean again? What's polynomial? Power of. Okay, that's why it's called a power rule. So it has to be a function where it's x to the power of n. In our case, when I first taught you, I said n was any whole value, positive whole value. So you could have n equals 1, 2, 3, 4, onwards. Okay? What was the rule again? So the derivatives, f dash of x, instead of doing first principles, what was the shortcut again? What's the rule? Very good. So this is the shortcut. Only applies if you have a power function or polynomial. So this is what you learnt in 17B. Then 17C, I had about 6 students who attended on the last day. That's 17C, I only extended one extra exercise, which then covers, well, what happens if you have -1, -2, -3 onwards. Okay, so 17C, you essentially, even with negative powers, you can still use power rule. Okay, today we're coming back, so I'm revising your power rule, but I'm also now letting you know you can also use power rule for what we call rational powers. What does rational mean? This is probably a term you would have learnt in year 9. What's rational mean again?
Can be expressed on a fraction.
Very good. That's in layman terms. It does mean you can write it into a fraction. Fraction, well, technically, the proper definition would be that you can write a value as a ratio of integers. That's what it means. If you break it down, what it's saying, it's just saying that you can write a fraction A over B where both A and B are whole numbers. Okay, that's why when you write fractions, never leave your answers as decimals. Don't mix fraction within a fraction. You don't leave your answers like that because that's not the definition what a fraction is. It's not a ratio of integers. Okay, so what they're trying to say here is when they're saying powers, they're saying you've got a rational power, meaning you can write this as a fractional power. So again, something like this, I'm going to do example 6a. So example 6a, we've got your function is x to the power of half. Notice they gave a condition. Why did they write x is greater than 0? Can someone explain to me why they have to put that? Because most times students will ignore that. Very good. Why is it impossible? Well, you can put 0 there. 0 to the power of half is what?
Can't square root negative.
You can't square root a negative. Very good. Okay, so it can be, it just has to be greater than 0. I mean, you can have 0, it's just that it won't be a function. Okay, so if we had x as 0, 0 to the power of half is the same thing as saying root of 0. Now, root of 0 is technically okay. There's nothing wrong with that. But why is that not part of the function? Because if you had x is 0, it's no longer an x to the power of half graph. It will just be a horizontal line at x equals 0 or y equals 0. Okay? So that's why they put a condition there. They're saying x can't be 0. This is kind of like your graph 1 on x. If I asked you what's the domain for this graph, you would know that the graph is rectangular hyperbole and there is no value here. Okay, so you can't have x equals 0. Well, same thing here. If x equals 0, the graph doesn't exist. Okay, so here we go. I'm just going to throw this out. Let's just go with what we're trying to find here. They want you to find the derivative or differentiate. And they say here, do it by first principles. Don't waste your time. Back in the past, we used to train your first principles. You don't need to. You can do it using power rule. So let's use our power rule for this question here. If f of x equals x to the power of half, and you know that the power rule is over here, n is the power, the derivative would be n times x to the power of n minus 1. Then what would the derivative be in this case here? What would this be? What's n equal to in my function? Half. Very good. Half is my n, so according to the rule, it is n, which is half, multiplied to x to the power of n minus 1, which is half minus 1. Let's work this out. This is half times x to the power of what's half minus 1? Negative half. And technically, some students will leave their answers there. One of the things that I encourage you to do for year 12 exams, do not leave your answers with negative powers. So this is where you got to use your index laws. How do I rewrite x to the power of negative half without having that negative power? What do I write? Well, how do I do this? Because you have to get used to that. You can't leave your answer here. Examiners will likely take a mark off. Okay, so you have to write it in positive integers. How do you rewrite x to the power of negative half? Very good. So again, same thing using index laws. Remember, negative powers you can flip. So this is the same thing as writing half times 1 over x to the power of half. Okay, if you've forgotten the rule, x negative 2 is the same thing as saying 1 over x squared. Well, I'm doing the same thing. X negative half is 1 over x to the power of half. When you multiply it together, numerator with numerator, denominator with denominator, this technically is okay. It's acceptable. But there's a better way of writing this. What's x to the power of half the same as? Root x. Very good. This is your preferred answer. Okay, so make sure to not leave your answers with negative powers. If I see that in your sacks, I will penalize you. Okay, so I will take it off as part of a mark. And obviously you do it many times, I won't be taking off that many marks, just once. Okay? But yes, keep it into positive powers, don't leave it negative powers. So that's how you would do a rational power problem. Let's take another example now. Let's try this one now. Okay, so you know this power rule. It's x to the power of 2/3, and this is x to the power of 1/5, x to the power of negative 3. You're combining what you've learnt previously, so let's try this again. Here we go. A, f of x is equal to 4x to the power of 2/3. Let's use our power rule. So power rule again, f dash of x. How do we do this? So some students might have forgotten. What do you do with a 4? Nothing. Leave it there. Don't be afraid. Just leave it there. Because remember, the rule only differentiates the power function. So we're only differentiating this section. That 4, leave it as it is. Nothing wrong. It's 4. Next to the x means times. Now you differentiate x to the power 2/3. So using your rule, what's my n value? What's n equal to? 2/3. Very good. 2/3. So 2 over 3. X to the power of 2/3 minus 1. And you follow through the same thing again. So here we go. 4 times 2/3 is the same thing as writing 8/3. X to the power of 2/3 minus 1. What's 2/3 minus 1? Minus 1/3. There you go. So this is what I meant early on in the year. I said those who struggle with fractions, struggle with the basics. It's not that you don't understand what I'm saying. You understand the method. It's a question of whether you can deliver. So how many of you are okay with fractions? How many are okay with your index laws? This is where it will show. Okay, so it's more of an algebraic problem rather than a conceptual problem. So here we go. You don't leave your answers negative power, so how do we write our answers? Write it as a fraction. So what would it be? So I can give you the answers, but I'm very interested in how you would do it. Good. So that's a good start. So we know we can flip the x negative third. You can write it as this. This is acceptable, but I like to write it in a different way. What's another way? You can rationalize denominator, but you don't need to. We can leave it as that. We just leave it as positive, but I don't want the index law. Cube root x. Okay, so that 1/3 is the same thing as saying the cube root of x. Half was square root to the power of a quarter would be 4th root. This is a more preferred answer, but if you left it like this, you won't be penalized. You left it like this, that's bad. Okay, don't write your answers negative powers. Either of these two is okay. The reason why this is more preferred is mainly because if you go through your exam papers, they often write it like that. You might get a bit confused, but it's still good to get to know your rational techniques with surds. Okay? All right, so we've done this one. Let's have a look at some of your problems in 20B. So I've only selected 1, 3, and 4 for you to do. The reason why is because question 2 and question 5 requires you to understand chain rule, and I haven't taught you chain rule yet. This is just to get you to practice. But let's have a look at question 3. So this time I want you to apply your understanding. If you can differentiate, that's one step. But what does it mean when you differentiate? So let's have a look at 3A. Let's have a look at 3A here. You've got question 3A says find the gradient. So that's the first step. You want to find the gradient of, you've got a function. It's a power function, but it's a rational power one. At each of the following points. Now, just to make your life easier, I'm just going to say let's do A triple I. Okay, so what are they asking you to do? How are you going to answer this question if they told you the point is at 1, 1, you've got a function of y equals x to the power of third, they want you to find the gradient. How do you do it? Have a go with this. I'm going to give you, let's say it's currently 2:21. Let's give it 2 minutes. 2 minutes takes you to 2:20. Actually, it's almost 22 already. Let's make it 2:24. And I'm going to ask you, what are you going to do to find the gradient? So it's one thing to be able to differentiate. It's another to be able to understand what it means. Okay, so what I've been talking about, tangent, gradient, at a point, how are you going to use this? Because this is the most preliminary type of question you can get to deal with derivatives. In the exams, you start to solve. So I want you to get your head around gradient, derivatives, and tangent lines. How do they link? What are they asking you to do right now? Have a go. 2 minutes. Yep.
Just a question about the exercises.
Yep.
Were we supposed to do continuity?
Yep, but later. So I'm.
There's a question for the 17F.
Yeah. So continuity links well with differentiability. So in order for you to understand what is differentiable, okay, so that links back to drawing derivative graphs. I haven't trained you guys to look at the meaning yet. I'm training you guys to be able to do, so how to differentiate first. Once you got that, then we can then look at, to me, the more conceptual part is how do you draw derivative graphs? That's what most Year 12s struggle with. And going back to your point there, what is continuity and what is differentiability? That's proofs section. So in the exams, they will ask you to justify your response, and you will need to be able to justify if it's continuous, and if it's not, why it will be differentiable or not. So at the moment, you wouldn't know that until I mention it. Dylan.
Endpoints on differentiable, right?
Points on
Endpoints.
endpoints.
Yeah.
Why?
Well, because the left limit is not equal to the right limit. Something like that. So, I can't remember.
Yep. You can think of it in terms of limits. If there was a left point, my other way of describing it as well on a sort of a logical plane, we talk about tangent line being it only touches at a point once, right?
That's basically giving that.
Correct.
So say there's no case.
Very good. No defined tangent line.
Yeah, but the thing about this is on the calculator, if you do like the tangent line at point 0 for like, let's say a power function x of real and 2, then you'll give you there's a tangent at x equals 0.
Yep.
You would say on the calculator, which is I think it's wrong because it's an endpoint at x equals 0.
3 on 2. Yes, it would be. It's just a square root cubed, so it should just be stretched. Yeah, that's true. I'm just thinking Kaz should have known though. There's an endpoint there. It is an endpoint at 0. And all endpoints do not have it's not differentiable at that point. I guess that's if we define that the tangent line was definitely, I'm assuming a vertical line or a horizontal line. If you define it, then you can get a gradient, but you can't be sure that that is the correct tangent line.
Yeah.
It could be so many other tangent lines that would work as well.
I also have another question on power functions, right? Do you think it's important to learn power functions, how to graph power functions?
How to graph power functions?
Yeah, so like in the form of x to the power of p divided by 3.
Oh, so like 3/4 or it will not this year, but definitely for next year. You don't, but it's good to. What it's good for, it's not about you sketching it. What's important about it is to analyze it. So the question of if I gave you like, if it's 5/3, 5/3, so x to the power 5/3, what is the reasoning to why it looks like you can predict what it should look like. So it's not about you memorizing 1/3, 1/4, 1/5. There's a pattern to it. And in year 12, they don't describe it specifically, but they just teach you even functions and odd functions, and to use those properties and your previous knowledge of square roots, third roots, and should then be able to see the pattern of whether it curves up or the curves towards the x-axis, whether it's an even symmetrical or is it asymmetrical shape. That's the skill you're taking out of it. So that means that in the exam, when you get square root functions in a fraction, you're meant to be able to determine what's possible, the domain, composite functions. You should be able to decipher them. That's the skill. So the skill is to be able to analyze an equation and to determine what can and can't be, and then to predict what the graph might look like. So you don't need to know it, but you need to be able to guess what it should look like. So like sometimes I look at a year 12 question and they say, what's 1 on root x? I don't memorize that. I just simply think about 1 on x is a rectangular hyperbole, but if you square root it, then what does it limit? And we know that we can't have negative graphs or negative x values, so then I know it must then look something like a rectangular hyperbole, but just the right-hand side, because that's where x is positive. So I imagine 1 on root x would have just the top right quadrant, so quadrant 1, and the left and right shouldn't have anything. So that's how I would analyze it, but it's not because I memorized it, but it's more on analyzing properties of functions. And that's what you want to learn from the x to the power of p on n. It's to allow you to be able to figure out what it should be. That's the skill they want you to take, but not necessarily to graph it. Graphing helps to visualize it. You won't need to, you just need to analyze it. All right, team. That was way beyond 2 minutes, but I'm assuming you would have got this correct. So, first step. Let's have a look. Gradient of y equals x to the power of a third. When you're looking for gradient, remember, you are finding the gradient of a tangent line. So whatever this x to the power of a third looks like, okay, so whatever it looks like, I'm just going to draw a random graph here. We know that we're trying to find the point, and there's a tangent line. That tangent line has a gradient. There you go, there's a gradient. They're telling you it is at the point 1, 1. So let's just say 1, 1 was over here. This is 1, 1. So that means my tangent line will look something like, something like this. So this line over here that I've just drawn, we are trying to find m. That's what they're asking you to do. So the only thing you have is x is equal to 1 at that point. The function that you have is equal to x to the power of a third. We know that to find m, that's the derivative at 1 point. So the first step that you should be doing already on a graphical sense, if I want to find m, I know that's the derivative with only 1 point. So I'm going to find the derivative first, because derivative allows you to find the gradient, right? So here we go. If f of x was equal to x to the power of a third, the derivative using power rule should be third x to the power of a third minus 1. And you should have a third x to the power of negative 2/3. And hopefully you wrote your answer with not a negative power, but you could have wrote it as x to the power of 2/3. And that's okay. Okay, you can change that to surd form if you like. So it could be a cube root of x squared, or you can leave it like that as well. Okay, so we've found our derivative. This is a gradient function. So for those who don't understand what I mean when I say gradient function, this just means you found a rule to find any gradient as long as you know what x is. X is a coordinate on the graph. So it doesn't matter what the graph is, as long as I know which x value I'm looking for. This is a rule that allows you to find the gradient for that particular function. We do know which point we wanted. We said at 1, 1. And the only x value we have is 1. So at x equals 1, I'm interested in knowing what's the gradient. This is the formula for the gradient. That's what you're doing. You're finding the derivative every time you use power rule, chain rule, product rule, quotient rule, that's what you're doing. You're finding a rule to figure out the gradient at any point, okay, with only 1 point. That's the idea. So I now know, okay, so at x equals 1, based on what I have over here, then the derivative, which remember, you're substituting 1 in. So f dash of 1 means at x equals 1, what is my gradient equal to, which is the derivative? It's 1 over 3 times 1 to the power of 2/3. Let's work that out. 1 over 3 times, now what's 1 to the power of 2/3? I know, it's scary, huh? What's 1 to the power of 2/3? 1. 1 to the power of anything's 1. Because 1 to the power of 2 is just 1 times 1. 1 to the power of cube root of 1 is the same thing. It's 1. So it's 1 over 3 times 1, and that gives you 1/3. And what does that mean? You've just figured out that line, that tangent line that crosses this function is at 1/3 of x. We just don't know what the y-intercept is yet. We don't know what c is. And that's what chapter 18 is. 18, you're then going to find c. If you're interested in finding c, how do you find c? How do you solve it? What are you substituting in?
Y equals, well, you put the coordinate, but the function itself is y equals 1 over 3 x plus c, and then substitute the y and the x, and then get c.
Very good. And that's chapter 18. Okay, so if you're sort of figuring it out, I gave you the pieces before. All you're doing now, if you piece it together, this straight line, the only way to find out c is you need a coordinate. But you know the straight line touches at 1, 1. That's the only point you got. So when x is 1, apparently the y has to be 1 because it's 1, 1. So you're substituting it in. You've got m, you can find c. That's exercise 18a. So you can see it's a problem-solving process, but you just need to understand what's derivative. What are you doing when you're finding the derivative? If you get that, then you won't find this exercise or chapter or topic hard. It's when you're only learning it blindly, which is what the average student would do. Most students will be able to learn how to do what I just showed you here. That's the average. It's the question of how do you then apply it. It's a very simple concept, but that's what the state generally finds difficult to understand. Okay, so that's what you're really trying to learn. That's it. Okay, now it's currently 2:34. I'm going to give you about 20 minutes just to have a go with. So I'm just going to write here gradients 1/3. I'm going to give you a bit of time, maybe 15 minutes to 20 minutes to have a go with 20B. Question 1. If you haven't done 7C, go back to 17C to practice some more of your power rules. And then I'm going to show you chain rule. Okay, so then I'm going to introduce you to chain rule, which will be a separate video over here. This is what I want to teach you. It will be the bread and butter for this week. That's what I'm going to focus on. Okay, so I'm going to ensure you learn chain rule really well, and that will apply to all other rules. So you can't move on without knowing your chain rule. Okay, but there you go. I'm going to stop the video here. Once it stops, of course.